This is day 2 on graphing quadratic functions, and when we're graphing, we're still using that chart form. So we've got 4 sets of directions today. 2 will be a review of yesterday, and then 2 will be new material. So let's take a look at the first set of directions that you'll see. It'll ask us to graph each quadratic function. You're going to have 4 problems like these 3 examples. And so what you're going to want to do is set up a little chart and try some numbers. And so we'll go ahead and plug some numbers in here. And we'll stick with our same familiar numbers. -2 is our first number we want to try. And we're just going to plug it in for x. Now when you square -2, that makes 4. So what we've got is 1/2 times by 4, which makes 2. And then -2 will give us 0. So when we're starting this problem off, we're going to go over 2 spaces to the left and up 0. So that's our first point there. And then our next value we'll plug in there is -1. And let's go ahead and substitute in for x here. So we've got 1/2 times by 1. When I square -1, I get 1. Well, 1/2 times 1 is 1/2. -2, well, if I take 2 from 1/2, I end up with -1 and 1/2. So here I have to go over 1 and then down 1 and 1/2 space. So I'll move on to my next point here. I'll plug in 0 for x. Now when I do this, I just get 0 minus 2 makes -2. So over 0 spaces brings me down 2 spaces. And then over here I move on to 1. When I plug in 1 for x, I end up with the same answer I did for this -1, because you see, if I square 1, I get 1 again. And 1 times by 1/2 makes 1/2, but I still got to take 2 away, so I end up with the same number of -1 and 1/2. But this time going to the right 1 space and down 1.5 spaces. Well, for +2, I'm getting the same answer I did with -2, because when you go ahead and you square the +2, you still get 4. And half of 4 is 2. 2 minus 2 makes 0. So over 2 spaces to the right brings us up 0. And there we've got it. We've got another parabola. This one opens a little wider than the last few that we had looked at yesterday. And the reason is because of the 1/2. So a big concept that we should look at, and we should hopefully notice after we've graphed a few, is this number is what makes the shape of the parabola. Everything else just gives us the location of where this value right here we call the vertex is. So this gives us the shape, and because we're taking a half of x squared, that means that it's going to end up only opening up not as fast as the other ones. It's going to open up a little wider. But this does open up, and again it opens up because it's a +1/2 y, so not -1/2 y, so let me fix that there. +1/2 x squared. So it's that 1/2, +1/2, that forces it to open up. And that's going to be the concept that we'll be looking at the next one here. So taking a look at this next problem, remember, if you see a minus sign in front of x squared, always treat that as -1. That's why I wrote -1 here, being multiplied by the x squared. So let's go ahead and try graphing this one. Again, we're going to start with those same numbers, -2 to start with. So if we plug in -2 and we square it, we get a 4. But you see how we're multiplying by that -1, and this is going to end up forcing us to always do the opposite of whatever number we're getting when we're squaring it. So -4 plus 3 brings us only down to -1. So if I go over 2 spaces to the right, or to the left, I'm going to end up going down 1 space. For -1, we plug that in, we square -1, and we get 1. But then we've got to multiply it by -1, which forces us down. Plus 3 gives us +2 this time. And so we're going to go to the left 1 space and up 2 spaces. And when we plug in 0 for x, it cancels out all the multiplication and exponents, so we're just left with that +3. So we're just going to go over 0, up 3 spaces. Now, because these graphs are symmetrical about this line we call the axis of symmetry, and which is in this case, in all of our cases so far, this y-axis. So this is our y-axis here and our x-axis. So we'll notice that when I plug in -1 for x, we square it, we get 1 again. Times by -1, we get -1 plus 3 gives us 2, the same answer we got right here. And so over 1 to the right, and that should be a positive 1 this time, so positive 1. Over 1 to the right brings us up 2 spaces. We plug in 2 for x, we end up canceling out. When we plug in this 2, we end up, again, getting 4. And we multiply by the -1, we get -4 plus 3 ends up giving us a -1. So if we go over 2 to the right, we're going to end up going down 1 space. So notice that this parabola is the typical shape that you're going to end up getting, but this one ends up opening down. And so the next set of directions is going to ask us whether a parabola or quadratic equation or function opens down or up. And the reason this one opens down is because of what is happening to the x squared term. And what is happening? Well, it's being multiplied by this -1 right here. So whenever it's a negative x squared, that's going to end up forcing this to opening down, because we're going to end up always taking the opposite of what we square. Well, we'll see that with this next one here. We'll see that this one, what do you predict it does? It's a positive 2x squared. Well, we're going to predict that this ends up opening up, so let's see if it does. Let's pick the same numbers, -2, so we square -2, we get 4, but then we got to multiply it by 2 and then subtract by 5. So that gives us 8 minus 5, leaves us with 3. So over 2 to the left, and we're going to end up going up 3 spaces. 1, 2, 3. Well, the next one here, -1, we're going to plug in -1 for x. We get 1. 1 times by 2 gives us 2. 2 minus 5 gives me -3. So if I go over 1 to the left, I'm going down 1, 2, 3. Well, when I plug in 0, 0 is going to put me right on the y-axis in this case. But only in this case, only when we don't have an x term here. We just have an x squared. And so it's going to cancel out our x squared term, because 0 squared is 0 times by 2 gives me 0. Minus 5 gives me -5. So over 0, down 5 spaces. Well, taking a look at the next one here, we have 1, and again, we predict that we're going to end up with the same -3. Let's see if we do. Let's see if we get -3 here. So 1 squared gives me 1. 1 times by 2 gives me 2. 2 minus 5, yes, makes -3. You'll notice that the reason it works that way is because we're squaring either a positive 1 or a -1, and we still get the same number of 1. 1 times by 2 gives us that same value of 2, minus 5 gives us -3. Well, when we plug in 2 for x, we end up with a 4 again. 4 times 2 gives me 8, minus 5 gives me the 3. So over 2 spaces to the right, I'm going up 3. I still need to plot this other one. Over 1 to the right, down 3. So notice that these graphs are symmetrical about this y-axis. And so we go ahead and draw this graph. And we just draw that smooth curve. Notice this one is steeper than the first one, and even steeper than the second one that we drew. And the reason was because we're multiplying the x squared term by 2. That means it's going to increase. It's going to double each of those x squared terms and make it go up just twice as fast. And so again, this one opens up, and it opens up because of that positive 2x squared. So that's the rule for the next set of directions. Tell whether the graph of each quadratic function opens up or down. Well, it opens up if the x squared is positive. It opens down if that x squared is negative. So that's what we're trying to do here. So what we need to do, though, is we need to get y by itself. So you always need to solve for y. That's the key. So we're going to go ahead and solve for y here by doing an opposite operation, getting it by itself. And so we can't determine whether the x squared term is positive or negative until y is by itself. And now y equals 7x squared plus 2. And we see that we have a positive 7, so that means this one opens up. Opens up. And the reason is because of that positive 7x. and have it 7x squared. And so then the next one, though, y is already by itself, so we didn't need to do any solving, so we just have to look at the x squared term. It's a negative 3, and because of that negative sign in front of the x squared term, that means this opens down. And then looking at the next one, here we have to get y by itself, so you just need to do an opposite operation. Subtract that x squared from both sides, or that 1/2 x squared from both sides. And when we do that, we're left with this y equals a negative x squared plus 4. And so which way is this going to open? Well, whenever that x squared term is negative, that tells us that we're going to end up opening down. So this one opens down as well. Well, and the next set of directions is going to go over the next part, which talks about range and domain, and then also talks about two new vocabulary words, a vertex, and then actually a maximum or a minimum point. So vertex is the real big vocabulary word we'll take a look at. So we'll take a look at graphs of quadratics again and what a vertex is.